Hi, I'm Venkat Bandi, and today I'll be presenting our research work done in comparing the usability of Chord and Sankey diagrams in visualizing flows. This research work was done along with Dr. Carl Gutwin and Aristides Mairena at the University of Saskatchewan in Canada. Many visualizations exist to show connections in flows, and designers have several choices when considering how to represent this kind of data. However, the two most common techniques for showing flows are chord diagrams and Sankey diagrams. Chord diagrams use a radial layout with a single circular axis as shown here in the image, which is visualizing the flow of debt between different countries in the world. Sankey diagrams, on the other hand, use a left to right layout with two vertical axes to show the same information as pictured here. Although both types are commonly used, chord diagrams have recently become popular both in mainstream media and in research communications and are used extensively for a wide variety of scenarios and datasets. And the main motivation for the study, in fact, came from one such instance of the use of chord diagrams in genomic conservation research. Conservation of genetic information is commonly visualized through flows as shown here, where each of the chord segments of the chord diagram are sections of DNA of a plant, and the ribbons connecting these regions are places where the genetic information is identical. Interestingly, as part of our daily work in building analysis tools for genome researchers, we found that although they used chord diagrams to summarize their work in publications, they often themselves preferred to use Sankey-style representations for their own data analysis, as they found them easier to follow and explore. This discrepancy was fascinating to us as visualization researchers, and in fact, it becomes evident in this example that you can see here, where there is a chord diagram at the top and a Sankey representation underneath it, both showing the same information. However, it becomes obvious that it's much more easier to comprehend the gene flows in the Sankey-style plot than the chord diagram. Although this is just one instance, it motivated us to study the design differences between chord and Sankey diagrams that can substantially change the way users extract information from them. So we performed an online study on 51 participants crowdsourced through Amazon's Mechanical Turk, where they used equivalent chord and Sankey diagrams to answer 5 different questions in 4 distinct datasets. To ensure there was no bias in the study against one type of visualization, both diagrams were developed to have equal areas on a 27-inch 1080 pixel monitor, and we also did not add any interactivity to either type, as the main goal of the study was to assess the diagram's ability to support pure visual interpretation. The main goal of our study was to compare the two diagrams in terms of time and error in answering questions and participants' perception of effort and their overall preferences. We were also interested in whether any differences between the visualizations were consistent across different question types and datasets, and whether these differences changed as users gained experience. This led us to the following within participants' factorial design as shown here, with 2 types of visualizations, 5 different question types, 4 distinct datasets, and finally the question iteration itself as a factor. Now let's see what the study looked like. In the main study, participants were shown a visualization and a text description as shown here that clearly indicated how to interpret the flow direction. And after this, they were asked 5 questions with multiple choice answers for each. The questions were selected based on realistic assessments that would be carried out when doing analytical work with flow diagrams. We also used prior research work into visual analysis work to devise 5 main question types, which are as follows. The first question type is related to existence, so participants had to determine if an entity or link exists in the diagram. For example, in the chord diagram shown here, is there a link from East Asia to South Asia? Other question types included finding an element that matched a particular criteria or one that is the maximum or minimum of its type. Or they also involved comparing 2 elements of the diagrams or identifying the number of elements related to a particular node. So now that you have an idea of how the study worked, let's get on to the results. The first result that we measured was completion time, which is the time needed for participants to correctly answer the questions. And across all the trials, the mean completion time for chord was 22 seconds, while it was 18.35 seconds for the Sankey diagrams. So in effect, participants were 3.7 seconds slower to answer with chord diagrams. We also carried out a second analysis of completion time in terms of participants increasing familiarity with the representations over the course of the study. And we found that participants improved as they gained more experience with the visualization, but there were clear significant differences between the visualizations, with chord substantially slower on the first question iteration than on the later ones. The second result we measured was errors, and across all the trials, Chord had more errors per question than Sankey, and additionally, there was also a significant difference in errors on the first iteration. After each visualization type, participants completed an RCTLX questionnaire, and one-way ANOVAs were then performed on each question using visualization type as the factor, and we found significant difference in terms of mental effort, perceived success, the amount of work required, and the frustration and annoyance caused. And in all cases, the test favored Sankey over Chord. Finally, at the end of the study, we asked participants which of the two diagrams they preferred for speed, accuracy, and overall preference, and for all questions, participants significantly preferred Sankey over Chord, both in terms of speed and accuracy. So what does all of this data mean, and what are the design implications in building visualizations like this? Well, here's what we have learned so far. Firstly, participants were faster in answering questions using Sankey plots, and this could be due to the left-to-right arrangement of the Sankey diagram. This was further evident through participants' feedback, which suggested that Sankey diagrams were easy to understand and were less confusing and less complicated to look at. A specific problem related to this involved link direction. As with Sankey diagrams, all links move from left to right, so it was relatively easy to determine the direction of the flow, whereas with chord diagrams, participants needed to spend additional time checking the direction of the links. Secondly, participants also appear to have more difficulty following links within the circular layout of the chord diagrams. One problem in particular involved interpreting the link arrowheads, as despite the large size of links in chord diagrams, participants found the arrows difficult to see. Another problem involved the thinning of the links in the center of the chord diagrams, making it difficult for participants to trace the links and estimate their weights. Thirdly, as seen in prior research work, the rotated representations may have caused problems for participants, such as difficulty reading the rotated text or keeping track of their start position when tracing the links. It was also evident that counting links was more difficult in the chord diagrams, and this could be because chord diagrams group incoming and outgoing links at the same node, meaning that users need to now carry out the extra step of visually separating incoming and outgoing links to properly analyze them. Finally, performance with chord diagrams was worse on the first iteration of every question type, which is an important result because chord diagrams have often been used in settings where novice users are unfamiliar with the visualization, particularly in mainstream media stories or scientific journals. This larger difference on the first iteration could be caused by the less familiar reference frame and layout of chord diagrams, as people require additional time to understand the overall approach and identify the steps needed to read the diagram. Of course, these results have led to a few questions that we still want to answer in the future. Firstly, our implementation of chord diagrams used only one node per entity for both incoming and outgoing links. But future studies could test whether duplicating the nodes and separating the directional links reduces interpretation problems. Secondly, future work should also consider larger datasets, as our hypothesis is that familiar left-to-right organization of Sankey diagrams will become even more valuable with larger datasets, and that the central clutter problem will increase for chord diagrams. Also, our diagrams did not include interactions such as zooming or hover highlighting in order to better assess visual interpretability. However, interactivity provides additional capabilities that could overcome visual limitations, and future studies should test these features out. Finally, the use of standard visualization parameters available in D3 limited us in terms of adding potential enhancements to our diagrams, but researchers have proposed layout metrics that could reduce clutter in both chord and Sankey diagrams, such as the example shown here to the left, where the clutter is minimized by reorganizing the layout of the chord diagram for the same dataset. And thus, to finally recap, what I'd like you to mainly take away from our research work is that despite the popularity of chord diagrams, designers should not universally rely on them for all flow data scenarios because they took longer to interpret and had more errors during analysis. Additionally, Sankey diagrams are also easier to read compared to chord diagrams due to their left-to-right organization, as that provides a familiar frame of reference for interpretation. Thanks for taking the time to listen to this talk.